right, we're going to look at a system of equations with three variables, and we are going to be looking at elimination. This is number 8. As we look at this, we're going to start by labeling our equations 1, 2, and 3. And what we are going to do here is we need to decide, do we want to eliminate with our x's, our y's, or our z's? Now, unfortunately, there aren't very many here that are going to just cancel each other out easily. The only thing that I see that's in common or that will multiply semi-easily is the z. If you look here, in the first equation and the last equation, we have the same coefficient, so that will be easy to switch. So we're going to use our z's to cancel this time. So when I do that, I'm going to take equation 1 and equation 3 and put them together. And then I need to take equation 2 on the other side and do something similar. So I'm going to take equation 2. I'm just going to go with equation 3 to solve on this one. All right? So I'm going to write these two out. We get 3x plus 3y minus 3z is equal to 21. Okay, down here we get 4x plus 2y minus 3z is equal to 21. All right? On this side, for equation 2, we have 5x minus 4y minus 2z is equal to 2. And then we have 4x plus 2y minus 3z is equal to 21. At this point, we already have the same coefficient on our z's. So we are going to choose one of them, and we are going to change our signs. We're going to multiply by -1. When I multiply by -1, I can literally go in here and switch every sign. So everything that was positive becomes negative. Everything that's negative becomes positive. When I add these, I get -3x plus 4x is x. I get -3y plus 2y is -y. And my z's eliminate each other. And I end up with 0 on my numbers. All right, I'm going to call this equation 4. And at this point, what we're going to do is we are going to come up with a way to eliminate and create one more equation on for our fifth equation. All right, I need the z's eliminated, so 2 and 3's least common multiple is 6. So I'm going to multiply my top equation by -3. I'm going to multiply my bottom equation by +2. Now, what you'll notice is I just randomly chose to put the negative on the top. We could do it on the bottom. It would make a lot of sense to do it there. Either way, it's going to work out in the end. All right, so I'm going to rewrite these. Get rid of this random 5 here. I'm going to say -3 times 5x is -15x. And I get plus 12y plus 6z equal to -6. On the second equation down here, equation number 3, when I multiply 2, I'm going to double everything in this equation. I end up with 8x plus 4y minus 6z equal to 42. All right. Now, this out just a bit. Write this down. Okay, so now I'm going to combine these two equations. I get -7x plus 16y. These go goodbye, and we equal 36. So I have x minus y is 0, but I have, for my fifth equation, -7x plus 16y is 36. At this point, I need to decide how I'm going to go ahead and solve this going forward. I'm going to take my equation number 5. Should just rewritten it. Negative 7x plus 16y is equal to 36. We can choose either the x or the y to cancel. In this case, it looks easier to just multiply the top by 7. I end up with positive 7x minus 7y equal to 0. When I combine these, I get 9y equal to 36, so y is 4, because we divided 36 by 9. So, when I come back up here, I can see that if I take this x minus y, I can replace the y with 4. X minus 4 is equal to 0, so x has to be 4 as well. So we have x is 4, y is 4. That leads us to need to find our z. I'm going to use this top equation, 3 times 4 plus 3 times 4, because x was 4 and y was 4. Minus 3z is equal to 21. So we get 12 and 12, which is 24, minus 3z equal to 21. So negative 3z is equal to negative 3, and z is 1. So we have 4, 4, and 1. So our final answer will be x is 4, y is 4, z is 1.